Hello guys, welcome to our video of the playlist called C# for Beginners. So imagine you are processing a collection of different shapes, circles, rectangles, triangles, and you need to figure out at runtime what specific type each object actually is, and then do something different depending on the answer. Let's see how we normally approach this. Maybe we have an object, maybe shape, and then some shape. Let's say we have something typed as a plain object. Genuinely, we don't know exactly what it is yet, just that it's some kind of shape. C# actually gives us a whole family of tools called pattern matching specifically for checking what is this and does it match a certain shape or condition. Cleanly, safely, and often in a single line, let's build up through all of them. Let's start with most basic version, just asking, is this object a specific type? Maybe we're gonna say object value equals maybe hello, right? An object holding a string, though its declared type is just object, genuinely generic. And then we're gonna have boolean is string equals value is string. Console.writeLine is string. Bool is string equals value is string is keyword checks at runtime whenever the value actually holds a string underneath, regardless of its declared type. This gives us a simple true or false back. So let's see the output. As you can see, it's true. And then we can do something like that. If value is string, console.writeLine it is string. As you can see, it's string. And naturally, this fits directly inside an if statement, exactly like any other Boolean condition, right? Is a simplified form of pattern matching, a straightforward yes or no type checking, but honestly, on its own, it's a little limited. Knowing something is a string does not actually give us that string to work with yet. Okay, that's where the next pattern comes in. So what if once we confirm something is a string, we actually want to use it as a string right away without separate casting step, right? Maybe we're gonna have object value hello if value is string text equals string value, and then maybe console.writeLine text.toUpper, right? This works, but notice we check if it's a string and then separately manually cast into an actual string variable before we actually use the string specific things like toUpper or toLower. That's genuinely an extra slightly clunky step, right? So let's see the output. Hello, and toUpper worked. So another way to do that is here is string value to let's see declare another variable, maybe here object maybe value 2 equals hello, right? And then if value 2 is string text right, string text console writeLine text dot to upper. Okay, if value 2 is string text, see what happened there. In one single expression, we are catching the type and capturing it into a brand new variable called text all at once. No separate casting needed, okay? So let's see the output in this case also. As you can see, it's returning the uppercase of the variable text that's created in exactly if block itself. This is genuinely one of the small features that removes a real blueprint, check and extract together in one clean line, right? Now remember switch statements from way back. What happens when we need to check against several possible types, not just one? This is exactly where switch and type patterns combine really nicely. Let me show you example. For example, we're gonna have function void describe, right, shape object shape, right? A method that takes an object genuinely representing an unknown shape, and then we're gonna have switch shape case int number console dot writeline. It's a number but I think it should work. Let's see, break. Okay. Case int number matches if shape is actually an int and captures it directly into a variable called number. Same idea as our last section, right? And then we're gonna have another case, string text console.writeline. It is a string text break. Okay. And same pattern, this time matching against string, right? Case null, for example, and then console.writeline. It is null. And then here break. And switch can even match against null directly as its own case, genuinely useful, connecting right back to last lesson's topic. And then we're gonna have default console.writeline, maybe unknown type, and then break, right? And let's see the outputs. Describe shape, maybe 42. Describe shape hello, and describe shape null. Okay, so and calling this with a few different values shows each case matching correctly based purely on the actual type of what we've passed in. So let's see the output. As you can see, it's a number 42, it's a string hello, it's null, right? Switch with type pattern lets us branch based on what type is this, cleanly handling several different possibilities, including null, all in one readable block. Okay, now let's go a level deeper. What if it's not enough to just know the type? What if we also need to check something about the object's properties at the same time? I'm going to show it with the class. Maybe we have a class person, public, string, name, name, get and set equals, and we have public int age get set. Okay, now we have person equals new person Alex okay, simple person class and one instance, right? And we're gonna check here if person.age greater than equal 18 console.writeline person.name is an adult. Perfectly fine, genuinely nothing wrong with this. Put pattern matching gives us an alternative worth knowing, right? And we're gonna have property pattern here if person is age console dot writeline person dot name is an adult. Okay, if person is curly braces age colon greater or equal 18, this is a property pattern. We are checking directly inline whether the age property specifically satisfies condition without writing person.age explicitly. Okay, and let me show we can check multiple properties at the same time. If person is age greater than equal 18, name equally not equal Alex, right? Alex. Okay, and then we're gonna write console.writeline. This is an adult. This is an adult. Name it Alex. Okay, we can check several properties at once separately by commas, all inside that same pattern. Age greater or equal 18 and name equals Alex, right? So let's see the output by running the code. As you can see, Alex is an adult, Alex is an adult. We are checking here with just conventional way, and then with property checking, and also multiple property checking. We are confirming that the person is adult, and also his name is Alex, right? Property patterns let us check the shape of an object state data directly without a long chain of separate and conditions, right? Genuinely elegant once objects have several properties you need to check together. You actually already saw a sneak preview of this in the last section, that greater or equal sign inside the pattern. Let's properly cover relational patterns on their own. For example, we're gonna have int temperature equals 15, string description equals temperature switch, and switch freezing 15, cold 25, mild, and then not default hot, right? Okay, and we're gonna say console.writeline description, right? Remember switch expressions from control flow a while back. Here each case uses relational pattern less than 0, less than 15, and less than 25, checking ranges directly without needing separate if-else comparisons written out by hand, right? And let me show the output here. As you can see, it's mild because it's less than or greater than 0 and less than 15, right? And now let me show the case with combining relational patterns, right? Let me show you. Maybe we're gonna have int score equals, let's close the terminal, int score maybe 85, and then we're gonna have string grade equal score switch, and then 90, and then Alex A, not Alex A, and then 80, and less than 90 B, and then 70 and less than 80, that means C. and default F. Okay. And we can combine two relational patterns together using and greater or equal 8 and less than 90. Genuinely reads almost like a plain English describing a specific range, right? So let's see the output. Console.writeLine. Great. B, right? It's working and checking the range because 85, our score is 85 and 85 is greater than or equal 80 and less than 90. Relational patterns let us express numeric ranges and comparisons directly inside a switch, which honestly reads a lot more cleanly than a pile of chained if-else statements checking the same thing. Okay, we've actually already used switch expressions a couple of times just now, but let's properly circle back and make sure this is fully clear since it's genuinely central to everything in today's lesson. Let's see the example with days of week. Int day number equals 3, string day name equals day number, switch, and then 1 Monday, Tuesday, 3 Wednesday, 4 Thursday, 5 Friday, 6 or 7, 6 or 7 weekend, and then default invalid day, right? Remember this from the control flow lesson. A switch expression directly returns a value using the arrow syntax instead of running separate statements. And notice this new piece, 6 or 7 arrow, weekend. The OR keyword lets a single case match multiple values at once, right? So let's see the output, console.writeLine, day name. Okay, it's Wednesday, right? And let me combine the switch expressions with a type pattern, tying all together. Maybe we're gonna have, let's just clear all of them. Object, we're gonna have object, item equal maybe 42, string description equals item switch, maybe int, and when and less than 0, and we're gonna say negative number, and we're gonna have maybe int and positive number, and okay, and then maybe string string s, and now nothing here, and default value, and unknown type here. Okay, but why actually it's not? Oh yeah, that because yes, so unknown type, yep. And then let's description. Okay, and here's genuinely the full power of everything we've covered: a switch expression, matching on type, capturing a variable, and see that when a keyword adding an extra condition on top, which is actually exactly what we're covering next. Okay, so let's see the output here. Positive number 42, right? And switch expressions are the natural home for pattern matching in C#, type patterns, relational patterns, and also property patterns. All of it can live directly inside one of these, arrow by arrow. Okay. Now, last piece for today, that when keyword, we just glimpsed it. Let's properly dig into how it works. Okay. Let me show another example. Maybe just delete it, and we're gonna have int number equals maybe -5, -5, and then string result equals number switch, and then int and when and less than 0, that means negative, right? And then int and when and equal 0, that means 0. Int and when and greater than 0, positive, and then here impossible. Okay, right. Console dot right line result. Okay. Int and when and less than 0, and arrow negative, and also int and when the n equals 0, arrow of 0. These kind of things. When the keyword adds an extra additional condition on top of a pattern match, so this case only matches if the value is genuinely an int, and also it is specifically less than 0 or equal 0 or the greater than 0. Okay, and it's kind of numeric situation, so let's see a bit realistic example with that. Before that, let's see the output here. Not run, and it's negative because our number is -5. Let's see some much more realistic example. Maybe we have our class person string, public string, name, get and set, and public int age, get and set, right? And then we're gonna have here person equal new person, and then maybe Alex, name Alex, and age equals 16 maybe, and then string category person switch, we're gonna put curly brackets, age less than 13, child. When person it's not finding person dot yep, actually we don't need this one. Okay, when person dot name equals Alex spatial teen, name it Alex, and age teen, just teen, and here adult. Okay, console dot right line category Okay, and here's a genuinely realistic combination: property patterns checking age combined with vanguard checking the name to, all inside one switch expression. Notice the order matters here. More specific cases need to come before more general ones, exactly like we learned the if-else chains way back, right? So let's see the output by running it. And as you can see, spatial teen named Alex. Why order matters? Because if you put that scenario before that, and then it's teen, as you can see, it's just showing error. It has already been handled by previous arm of the switch expression, or it's impossible to match. As you can see, we already defined here, so it's saying it never comes here because if it satisfies this situation, okay? And to summarize, when the guards let you let you attach extra arbitrary conditions onto any pattern, genuinely opening up pattern matching to handle almost any logic you can imagine cleanly inside a single switch. Okay? And alright, let's close this out with a realistic example classifying a different kind of orders for a shipping system. Let me show you that example. Maybe we're gonna have class called order, and then we're gonna have public double total get and set, and public pool is express shipping. It's express shipping get and set. And here we're gonna have object items equals new order total equal maybe 150, and it's expressing shipping true, and then here not an order, and 42, and then null. Okay, and then for each object item in items string result equals item switch order, or when order.total greater than 100, and order dot is expressing why it's not seeing the order greater than 0, and maybe here, not and order dot is express shipping priority express order order total 100 large order, and order standard order string maybe s unexpected text s and now missing item, and then default unknown item type, maybe unknown item type, right? Okay, and then you're gonna have console inside the loop console.writeLine result I think the problem is here with that, not an order 42 and null, but what's wrong here? Order O when order total is greater than 100 and order is express shipping. Maybe O, and this one is also O, and I think AND one is not working. Oh, why? But why? Why it's not working? Let's write it. Order O when O dot total is express shipping. Yep, it's working. It's seeing the values total greater than 0 and 100, and here, and it's not seeing AND operation. Why it's like that, I have no idea. And then we can do something like that. Okay, as you can see, the mixed array, an actual order object, a plain string, and a number, and now for each item we run it through a single switch expression combining a type pattern, property pattern, and when a guard together to correctly classify each one, whatever it turns out to be. Okay, so let's see the output, but I have no idea why and it doesn't work here. Build failed, fixed error, or where is the ah that's why. I think it should run now. Oh, clear, and then .NET run. It worked large order, and let's try the one that I want to try here. Order O, and then when order dot total greater than 100, and it's still not working. Why? I have no idea. Maybe order items. We are initializing a new order, and then total, and here I can understand why it's not working with AND, but as you can see, we are getting the values unknown item type for the null situation, and also unexpected text not an order, and missing item, and also large order because our order is greater than 100, like that. Type patterns, property patterns, and relational patterns, switch expressions, and when guards all working together in one clean block, okay, instead of tangled mess of nested if else statements and manual casting. So that's all for today's lesson, and I recommend you to do research on maybe Microsoft's official documentations to get much more experience and knowledge about that. And your challenge for today's lesson would be writing a switch expression that takes an object and returns a description, empty string if it's an empty string, a long string if it's a string over 10 characters maybe, and short string for any other string, and not a string for everything else. Use property patterns and when guards where it makes sense. Okay, so today we covered type checking with is, type patterns with variables, switch statements combined with type parameters, property patterns for checking object data directly, relational patterns for numeric ranges, switch expressions, trying it all together, and when guards for attaching extra conditions on top of any pattern. Pattern matching is genuinely one of the C-Sharp's more elegant modern feature. It takes what would otherwise be a tangle of it else at manual casting and turns it into something clean and readable. Next time we are moving into advanced types, tuples, anonymous types, and extensions methods. See you there. Take care.